So what happens if you have a very complex Spark driver script that actually has a lot of third-party dependencies that aren't part of the core Spark distribution? Or maybe you have a bunch of add-on packages you need to manage. Well, SBT is a technology you can use to actually package up all of those dependencies into a self-contained jar file that you can just move around to your cluster and run with one very simple line of code. So if you're familiar with the Maven for Java, you can think of SBT as Maven for Scala. It's basically a dependency management tool. So, like I said, if you get into more complex scripts where you have a bunch of third-party dependencies, and this is pretty easy to do because sometimes your dependencies have dependencies and whatnot. For example, if you're trying to use the Cassandra database connector from DataStax with a Scala script, maybe you need to integrate an output to a Cassandra database, that's going to pick up this whole tree of dependencies that the Cassandra connector package depends on. So not only do you need to deal with having the Cassandra connector library installed on your cluster, you also need to make sure that all the dependencies of that library and all their dependencies are installed as well. So it gets to become a very complex problem if you have enough of these things in one place. SBT manages that for you. So all it is a very simple way of packaging up an application for Spark using Scala and automatically pulling in all of your dependencies and making sure that all the dependencies for your dependencies are in place as well. And it puts it all into one big, nice, neat jar package that you can then just copy to your cluster and run. So to use SBT, it requires a very specific directory structure that you actually create your packages from within. So you need to create a directory structure that looks like this. You basically need a project folder and a source folder alongside each other. And under your source folder, you will have a main folder and a Scala folder, and that's where your actual driver script source code will go. So you have to set that up by hand, but once you actually do that, actually running SBT is quite simple. The other thing you need to do is add this little extra step here for a Spark and Scala. You need an assembly.sbt file inside the project folder, and it just needs to be something of this format. Now the details of this command line will probably change over time. This is what works right now with the SBT 0.13.11 release. But SBT assembly is just what exposes the means for actually exposing the command for running SBT to create a self-contained jar file that contains everything you need in one place. The next thing you need is an SBT build file, and this is where you specify what your script depends on. And SBT will then be responsible for getting that chain of dependencies and making sure everything's in place. So we need to specify the name of our class that we're going to be running with, give it a version number, we'll call it 1.0. Organization, from your package name, and the Scala version that your code depends on, which in our case will be 2.10.6 right now. Then you need to specify any library dependencies that your script has. And since this is a Spark script, we do depend on the Spark core packages. So this line says I need the entire set of libraries for Spark core, or else my script can't work. Now here's some more interesting pieces here. You also specify the version of Spark that you're depending on. In my case, it's going to be 1.6.1. 1.6.2 is already available as of recording this, so that will probably be different by the time you actually run this stuff. And important here is that I'm saying it's provided. So if I already know that these libraries are going to be pre-installed on my cluster, I can say in this build file, they're already provided, they're already there. I don't need to actually package these up in my final jar file. And as it turns out, we're going to be running this on an Elastic MapReduce cluster using Amazon Web Services, and I know that comes with all of the core Spark libraries pre-installed, so there's no need to actually package those as part of my script. But if you did have dependencies that weren't part of a standard installation, that's where you would put them. So here's an example of putting in Kafka as a dependency. Kafka is basically a technology for streaming large amounts of data from a distributed fleet, say log files from a giant web server or something. So if I had to do something like that, I could say, okay, from the org.apache.spark repository, I need the Spark Streaming Kafka package that works with Spark 1.6.1. And by adding that into my library dependencies, SBT would know that I need to go and retrieve that package, make it part of my jar file, and also retrieve any dependencies that package may have, which it turns out there are quite a few. Okay, now in this case, again, make sure I'm using the correct Spark version number that I will have deployed on the system that I'm running it on, and note that I did not put provided on that line because it's not actually pre-installed. I really do need to include this within my final package. Once you have all those bits in place, all you do is go up to the top directory and run SBT assembly. And it will automatically go create your jar file that contains any dependencies you might need within it. And you'll find that output jar file inside your target folder that gets created inside the Scala folder that's specific to the Scala version that you're working with. At that point, you can take that jar file and just run it. So what's really cool is since you gave it the name of the class you actually care about as part of the assembly, the build file, you can just say spark submit, type in the jar file, and everything else just happens. You don't even need to specify the class name. You won't need any jars dependency options because those are already contained in the jar file. So just by saying spark submit, file name of the jar file, you're done. That's all you need to do. Just make sure your jar file is copied to where you're going to run it from, and you use spark submit to kick it off, and that's all you need to do. So it makes life a lot easier when you're actually deploying stuff. And remember, time is money when you're on a cluster, so by making the process of actually running this on a cluster as simple and painless as possible, that's going to save you money in the end. So let's try it out. We have a new version of our movie similarity script that we're going to actually run on a real cluster. So let's take a look at that real quick and package it up using SBT. All right, let's actually package something up using SBT for real, and we're going to actually deploy this to an actual cluster and run it later in the course. So first things first, if you don't have SBT installed, head over to the scala-sbt.org website here, and you'll see a big friendly download button. And you can download that for Windows or whatever platform you need to deal with. And I'm not going to waste your time going through the installation of this on Windows. It's just your standard Windows installer. So go ahead and take care of that if you need to right now. Hit pause. I'll still be here waiting for you. Done. All right. The other thing we are going to be doing is actually packaging up a 1 million ratings version of our movie similarity script. So that's going to be kind of the end game of our course here. What we want to do is actually create movie similarities using 1 million movie ratings on an actual cluster. Now, you don't have to actually download the data, but if you do want to look at it, if you go to grouplens.org under datasets, just like we did for the 100,000 rating dataset, there's also a 1 million rating dataset. A little bit newer from 2003. And if you want to click on the readme.txt file here that comes with the dataset, it gives you more information about the file formats. They are a little bit different. So, for example, the ratings data themselves is in a ratings.dat file now, and it's actually separated by these double colon characters. So a little bit of a different format there. The movie data itself is also a different format. It's in movies.dat, and again, it is separated by these double colon characters. So our script will have to take that into account. So let's take a look at the actual script we're going to package up. If you go to the Scala IDE and you import the movie similarities 1m.scala file from the course materials, we've done that a million times, I'm not going to walk through it again, you'll see it looks a lot like our movie similarity script with a few key differences. So, for example, we have modified our mappers that parse out the information to take into account the new file names and new delimiters that we have. So we're looking for movies.dat now and a colon delimiter here. A little bit different. We also need to think about where these files are going to be when we're actually running on a cluster. So you'll see I'm actually saying I'm going to load this up from movies.dat right alongside whatever directory I'm running from. So the way my strategy here is to make sure that movies.dat is distributed next to my Spark driver script. And I'm going to load that up as part of the driver script and make sure that it's in the directory that I'm actually going to run from before I start. Now, movies.dat is small enough that I can get away with that, but when we're dealing with a million ratings, you know, we're getting into big data here. Maybe we want to make sure that that's someplace distributed and more redundant. So if you scroll down a bit, you can see that we're also going to be loading the ratings.dat file from S3. So this S3N prefix says, instead of loading from a local file system, I'm going to go to Amazon's S3 service, which is a big distributed file store, and look for the Sundog Spark bucket and load it in the data from there. So this way I can make sure that the ratings data itself is accessible to every node on the cluster because S3 is available to every node on my Amazon Elastic MapReduce cluster. And it also ensures that that data is in a place that can handle the size of it and can store it redundantly. Okay? So a little bit closer to a real world scenario here. If you're on a Hadoop cluster, that might be an HDFS link instead of S3N, for example. That would work just as well. All right, the rest of it's going to be pretty familiar. There are a few other differences here that we'll talk about a little bit later. For example, how we're using a hash partitioner here. That's an important step. One other thing worth noting too is that we're not actually specifying local star when we're creating the configuration for this script. So instead, we want the existing configuration on the cluster to take over. So when we set up an elastic MapReduce cluster, it will come pre-configured to take the best advantage of the cluster at hand. So it will know how many nodes it has available to it and how to split that up. Now, if I forgot to do that and I actually left that local bracket star bracket in the Spark conf, it wouldn't actually take advantage of the cluster. That would override any setting on the cluster itself and actually just run on that one machine. So important to remember that step. So I haven't actually specified how this Spark context is going to be run. I'm going to fall back on the configuration files on the cluster itself. The only thing I'm going to set is the application name itself. So I'm going to create a Spark conf folder on that conf object, Spark conf object rather, set the app name on it, and then create my Spark context using that Spark configuration object explicitly. Okay, so a little bit different way of setting up your Spark context when you're running for real on a cluster. With that, let's package it up using SBT. Pretty simple stuff. So if we go to the downloads folder for the course, you'll see an SBT folder where I've kind of set everything up for you already. So that's pretty cool, huh? Let's just copy that somewhere that we can work from. I have a handy dandy E drive. I'm just going to copy it there. And if we open that up, you can see that I've already created a build.sbt file here. If you open that up, you can take a look at it. And we've specified the name of the object as Movie Similarities 1M. You gave it version 1.0. It's under the com.sundog software organization. Depends on Scala 2.10. And its only dependencies are Spark Core. We're not actually using any fancy third-party dependencies. And we're going to specify that we're going to be using Spark 1.6.1. And these Spark Core libraries are already provided on the cluster itself. Now, if I did have weird third-party dependencies, this is where I would add them in. And SBT would handle making sure that they were available and part of the package. The other thing that is in here for you already is under the project folder, an assembly.sbt folder file. And again, this may change from SBT version to SBT version, but for this particular version of SBT, this is the magical incantation that needs to be there. So this will just add access to the SBT assembly command that I can use to actually make my final jar file. And you can see I have a source folder that I've created there as well. That already contains a main folder and a Scala folder. And under source main Scala is where I put the driver script itself that I want to package up and ultimately run. Okay. So the rest is kind of magic. Since we're actually creating just based on this one Scala folder, SBT will understand that the main function in that object is what I actually want to run. And I don't need to actually explicitly specify that when I actually run Spark Submit anymore. So let's spark up a command prompt and actually create that assembly. I will switch to my E drive and CD to that SBT folder that I created. Take a look. Yep, everything's there. And from this level, all I have to do is type in SBT assembly, just like that. And if I've properly set up my build.sbt and SBT assembly, it will go and find that driver script and package it up. So it's going off, making sure there's no dependencies that it needs to retrieve. And ultimately, it will create a jar file. SBT is a pretty complicated package, so even for simple tasks, it can take a little bit of time to finish. Looks like we're about done. There we go. So, what did it do? Well, if we go back to our SBT folder here and we go, ooh, there's now a target folder. Let's open that up. And under there, there'll be a Scala 2.10 folder, since I specified Scala 2.10 as my dependency. And there is the final jar file. So that is the jar file that I actually need to distribute to my cluster. And that is my Spark driver script that I can run from a real cluster. And we're going to do that next and see how it works.